Hello everyone, welcome to Codes Camp. Hope you're all doing great. So this video is all about, as you can see in my screen, learning what is time complexities and the basic big O notations we frequently use in our programming. So time complexities has a lot to cover, but here we are going to see few frequently used notations with examples and exercises, and we are going to learn how to evaluate your algorithm's time complexity. So let's get started. So what is a time complexity? In simple words, time complexity is the amount of time taken by an algorithm to execute. So you can get the time complexity by counting the number of operations performed by your code. So why do we need time complexity? So time complexity is used to evaluate the effectiveness of your algorithm. For example, if you are having a problem and you have 5 different solutions for the same problem, in that case, which would be the best solution and how would you pick it? So there comes the role of time complexity and space complexity. They are used to find the most effective algorithm in terms of time and space. So let's keep the space for future and let's dive into the concept of time here. Theoretically speaking, time complexities are represented as big O notations, omega notations, theta notations, and much more. Here we are going to cover few important big O notations that we frequently encounter while solving a problem. So here comes our first notation, which is nothing but big O of 1 or constant time. So constant time is nothing but the algorithm that takes same amount of time to compute regardless of the input size. Consider this example where we are given an array which is already sorted, and the problem statement asks us to print the minimum element or the maximum element from the sorted array. So in this case, in any sorted array, you will know the first element is going to be the minimum element and the last element is going to be the maximum element. Irrespective of the size of the array, whether the size of the array can be 100, 200, 10,000 and so on, but every time the first element and the last element of the array is going to be the output. In that case, we don't need any iteration or any number of steps. We can directly return our output. So that is what means constant time. It is taking direct time. That is, you can access your data directly. Consider the second example, that is print the third element from the array. This is again the same thing, that you can straight away return array of 0 as our output irrespective of the size of the array. So these kind of algorithms really take constant time. So some of the other examples of constant time are finding whether the number is odd or even. So straight away when an input is passed, you can, in one operation, you can return the value. Accessing a data from a hash map. So hash maps are having key value pairs. If you are trying to access any data of any particular key, you directly go to that key and access the data instead of iterating the whole hash map. So that is again going to take big O of 1 or constant time, or performing any addition, subtraction or multiplication is another example. Simply you can compute the value and return it. So hope you're understanding the constant time complexity. Let's move on to the next, which is linear time complexity or big O of n. Linear time complexity algorithm are taking time that are proportionally longer to complete as the input grows, or in simpler ways, it is based on the input or length of the input given. So consider this example. Here again we have an array but which is not sorted, and the first problem statement says print all the values in the array. So in order to print all the values, you need a for loop which iterates from the first element to the last element of the array and print everything. And it has to iterate all the element in your given array in order to print the code. So you are repeating the same code for n number of times, which means it is going to take big O of n time to execute this particular code snippet. So moving to a second problem statement which says find the maximum or the minimum element in the array. Unlike our previous example, our given array is not sorted. So to find the maximum or the minimum element from the array, you need to iterate the complete array to fix the value. So again, you need the code to run n times to find your maximum or minimum element. Same way, sum of all elements of an array. So here if you want to calculate the sum of a given array, you have to iterate the complete array and return the sum. So hope you're understanding this time. So let's move on to the next one. So the next time we are going to see is logarithmic time. So logarithmic time is nothing but that divides the problem in half every time. For example, you want to search a book in a library that starts with a title with its first character as S and it is regarding a science book. You go to a library, you want to get that instead of going through all the books in the library, you would search for the science section. So in that case, you will skip all other sections and directly move on to the science section. And in science section, the books are arranged in alphabetical order. So not by searching first right from the first book, you'll directly go from where the book starts with the character yes and search your book, so that you don't really have to refer or check all the books in your library, but you somehow searched and managed to pick your book by reducing your work to half at every stage. It is very similar to that. If your iteration reduces to half every time, then it is working in a logarithmic time. So consider this example. Again, you have an array which is sorted. The first problem statement says search for an element in a sorted array. In other words, it is a binary search. If you want to search the element 3, in binary search, you would look for the mid element. And if it is greater than your target, then you will be searching your input or target in the first half of the array. If not, you will fix the searching in the second half of the array and further looking for the mid element, and further you'll reduce your input every time half. So that actually means or logarithmic time. So again, look at the second example or the second problem statement, that is search for an element in a binary search tree. As we all know, the binary search tree is going to be having the alignment that all the left children are going to have the lesser value and all the right children are going to have a higher value. So if you want to look for the value 3 in your binary search tree, then you'll check the root element, and if the root element has the higher value, then you fix your search towards the left side. Otherwise, you'll fix your search towards the right side. And if you fix your search towards left side, you will completely ignore what is in the right side. So that actually reduces your input or search space half to every time. That is again says it is running in logarithmic time. So let's move on to the next one. So the next one here is quadratic time. So quadratic time is nothing but, consider a classroom which is consisting of some 20 people or n people, and each of them has to go to every other person to introduce themselves. So the first student starts going to everybody's place and doing a handshake and introducing themselves and coming back to his place. And again, the second student start and go to every other place. So which is simply quadratic time. That is nothing but n student interact with every other n student, which in turn can be represented as n square. So that is what it says. The running time increases non-linearly with the length of the input. So consider this code snippet. Here we have two for loops or nested loops. So for every n in the first iteration, it interact with every other n in the second iteration. Same way, when it moves to the second one, again it interact with every other n. Again, for the third one, it interact with every other n in this nested loop. So consider this example. The first one says printing a n cross n matrix. Here in this case, you will use a nested loop and print the values of the matrix. Same way, maximum sum of subarray, though they have optimal solutions, if you are approaching that problem in brute force way, then you again need two for loops and possibly check every size of the subarray and return the output or calculate the sum. So this is called quadratic time. If suppose you have one more for loop and again it runs for n time, in that case you will be running your input for n into n time, and that is equal to n power 3, which is nothing but cubic time complexity. Same way, if you have more for loops and execute more than n times, then in that case n power c is the time complexity, where c is the count or number of times you have a for loop and execute your input. So hope you're understanding this. Before moving to other big O notations, here is the poll I have posted in my Coders Camp Facebook page as well as in my LinkedIn, and asked to compute the time complexity for the following code snippet. But unfortunately, most of you have answered it wrong. But congratulations to those 35% who answered it right. And the answer is big O of n plus n. So let's understand how this works. So here we have a code snippet for printing the values of array A and then again a for loop to printing the values of array B. So I have posted this poll to differentiate between the two complexities of n cross m and n plus m. So where to multiply the complexities and where to add the complexities. So as you all now know, n cross n or having a nested for loop will give you the product of complexities. So consider this code now. You have one for loop to print the array A. Let's consider size of array A is n and size of array B is m. So it completes this operation. As I said, for one for loop, it is going to take big O of n time. And n is nothing but size of your input array. Same way to print the values of array B with size m, going to take big O of m time. So this time plus this time is the overall time of this algorithm, and you can represent this as n plus m. So this is the actual output for this problem. So consider this code snippet. Here we again have a nested for loop, where in our previous time complexity we have seen if two for loops are running for the same size, then you represent that as big O of n square, which is nothing but n cross n. Same way, if you have two for loops of different sizes of n and m, then that can be represented as big O of n cross m. And this is actually called polynomial time. So polynomial time is again the same thing, that increases non-linearly with the length of the input but changes based on the size. So better example to explain this polynomial time is printing an n cross m matrix. So if the matrix size is 2 cross 3, then we have to execute that many steps or it iterate with two nested loops of size 2 cross 3. So hope I'm making some sense now. So the next time we are going to cover is linearithmic time, which is nothing but combination of linear and logarithmic time. So which runs somewhere between the linear time and the quadratic time, which is nothing but it is slightly taking more time than big O of n, but not gonna take that much time that is of big O of n square. So the perfect example to explain this time is sort and print the array. So consider the following Java code where we have used a predefined function to sort our given array and then printing all the values. The backend of Java, that is the sorting algorithm in Java, is going to take big O of n log n time complexity because it uses the merge sort. So again, if you dig deep into the merge sort, it is going to divide the input, sort them, and then combine them together. So as it is dividing the input to half every time, it is going to take logarithmic time. And we are going to iterate the values once to print the values, and that is going to take big O of n time. So overall it is going to take n plus log n, which is big O of n log n time complexity. Next, moving on to exponential time. Exponential time doubles every time as the input grows. So the example to explain this is recursive calculation of Fibonacci series. So consider the code of recursive calculation of Fibonacci series here. For example, if you want to calculate the Fibonacci series for 4, in that case 4 is going to call 3 and 2, and again 3 is going to call 2 and 1, and further 2 is going to call 1 and 0. So again this 2 is going to call 1 and 0, and further it goes on as the level grows up. So if you consider, it is going to add up power of 2 at every level. So it is going to take 2 power n iterations. N is nothing but the input size or the depth of the tree represented here. So it is going to take exponential time. And let's have a quicker look at the next time, which is factorial time. So as we all know, factorial is nothing but multiplying that number with its decreasing order till it reaches 1. So as you know, this is going to give you more value. The same way the time is going to be more. The perfect example to explain this is permutations. For example, if you want to print all the permutations of 1, 2, 3. So the permutations of 1, 2, 3 is going to be having 6 different sets, and that is actually 3 factorial. So 3 factorial is nothing but the length of the given string or the number of digits in the input. So 3 factorial is 6, and actually we have to iterate 6 times to print all this output. As this is going to take more time, we have to stay away from this time complexity, as if we are arriving at this solution, then it is going to time limit exceed. So now we have covered most of the common notations we have been using in our programming. So let's understand few rules of time complexity to compute your own algorithm's time. So the first rule we are going to see is drop the constants. So I have taken few examples from cracking the coding interview book. So let's see our first example, which is going to calculate the maximum and the minimum element from a given array. So both code snippets are going to do the same job and return the same value. But in the first example, we have iterated in a single loop and updated both the values of max and minimum. But in second example, we have two for loops. In first for loop, we are updating the maximum value, and in the second for loop, we are updating the minimum value. So if you compute the time complexities for these two examples, in first example, we clearly know as we are iterating it only once, we are going to take big O of n. And in a second example, as we have already seen, one for loop is going to take big O of n time. And here we have two for loops, which is actually going to take big O of n plus n time. So you must be clear by now, we are not having a nested for loop. If we have, then it must be n cross n. If we have separate for loops, then it is n plus n. As this is n plus n, you will add these two n's and this is going to become 2n. And the rule is, if there is a constant, either it is small or big, there can be 500 yen or 1000 yen or anything, you can ignore this constant. And again, this time is actually big O of n only. This is the first rule. So here is a second rule, which is nothing but drop the non-dominant term. So consider this code. Here we have printed our array once using one for loop, and we have two nested loops, and these nested loops are adding the values and printing it. So if you compute the time complexity of this algorithm, it is going to take big O of n, and this part is going to have big O of n square time. And overall, you can represent this as big O of n plus n square. As n square has more value and n is a simpler value or non-dominant term, you can simply ignore this from your algorithm's time complexity and you can represent this as big O of n square. So in your time complexity, if you have any constants or comparatively lesser time, you can ignore them and round it off to a higher value. So that is what these rules says. Finally, coming to the trickier part, what is the time complexity for recursive function? So first consider this code in order to understand this. This code calls the same function again and again recursively for -1 value. It is very similar to the code of Fibonacci, but instead of n minus 2, it is calling n minus 1 both the times. For example, you want to compute the value for 4 and your recursive calls are going to look like this. That is, 4 is actually going to call 3 and 3, and 3 is going to call 2 and 2, and 2 is going to call 1 and 1 till it reaches 1. That is the base condition given in the function. So what is the time complexity of this particular recursive call? So here every call is branching to two other calls. That is, for every function it is going to call two other functions. And here the depth is going to be 4. It is nothing but at every level the input doubles. That is, at first level it is going to call 2, and second level it is going to call 4, and third level it is going to call 8. And every time it is exponentially doubling, which is nothing but 2 power 4. So 2 here is nothing but the number of calls at every level. That is, for one function it is calling twice, and 4 is nothing but the depth of this tree. So overall, most of the time complexity for a recursive function is going to follow this pattern. That is nothing but big O of branches power depth. Branches is the number of function calls from one single function, and the depth is nothing but the depth after you represent this as a tree. So most of the time recursive calls are going to follow this, but not every time. So yes, we have covered enough about time complexity and common time complexities that we have been using in our programming. Hope you all understood up to some extent, and the time complexities we discuss in every video is the combination of all this only. So I have been posting few time complexities quizzes in my Facebook page. Do participate and comment the answers below, and we are going to discuss those answers once we are done with the polling. So let's meet in the next video about time complexities with answers to those polls. So stay tuned till then. Thanks for watching the video. Hope you like this video. If you like the video, hit like, subscribe, and let me know in comments. Thank you.